All right, this is Algebra 2, target number 38. I can use trigonometry to solve right triangles. With this target will be broken up into three parts. Okay, in the first part, we will just be defining trig ratios. Part of this should be review for you from geometry, but we will be adding a few things as well that will be new. All right, so let's first talk about the trig ratios. The trig ratios are ratios of side lengths in a right triangle. So if we consider a right triangle, okay, that has an acute angle of theta right here, okay, that is the Greek letter theta. Okay, it's basically a zero with a horizontal line through the middle. Okay, the three sides of the triangle are the hypotenuse, the side opposite theta, and the side adjacent to theta. So when we identify the three sides, we should know that the longest side is always the hypotenuse. So if we identify where the hypotenuse is first, okay, that's the longest side. Then the side that's adjacent will be the leg that helps the hypotenuse create the angle we're looking at. Okay, so if this side helps create that angle, okay, of theta, okay, that is the adjacent side, which then leaves the only other side, right, by process of elimination, okay, as the opposite side. All right, so if you look at all of the different possible ratios of those three sides, okay, and again, a ratio just means a fraction, right? So if we take hypotenuse over opposite, opposite over adjacent, adjacent over opposite, adjacent over hypotenuse, all of the different combinations of ratios of those three sides, okay, those create the 6 trigonometric functions. Okay, so trig functions. And those are called the sine. Okay, S-I-N-E is pronounced sine. Okay, just like a stop sign. Okay. Cosine, tangent, cosecant, secant, and cotangent. Right, so sine, cosine, tangent, cosecant, secant, and cotangent. All right, and the abbreviations that we use, okay, for those, for sine, it's just S-I-N, cosine is C-O-S, tangent is T-A-N, cosecant is C-S-C, secant is S-E-C, and cotangent is C-O-T. All right, so that's how we identify our 6 different trig ratios. Now, how do we define them? All right, so 3 of these you should be familiar with. The sine, the cosine, and the tangent you were introduced to in geometry. So if I have my angle theta is my acute angle of my right triangle, then the sine, okay, is equal to the opposite. Okay, so sine is equal to opposite over hypotenuse. Okay, cosine is the adjacent over the hypotenuse, and tangent is the opposite over adjacent. Right, so if we look at those 3 definitions of those trig ratios, okay, this is where the so, ka, toa comes into play, right? Because that gives you the 3 definitions of those first 3 trig functions, the sine, cosine, and tangent. All right, so again, what does that mean? Okay, well, S stands for sine, okay, right, sine. Okay, O stands for opposite. Okay, H stands for hypotenuse, right? And then the same thing for CAH is cosine adjacent over hypotenuse. TOA is tangent opposite over adjacent. They're the definitions. Okay, this is how we define these 3 ratios. And again, they're just the sides of that right triangle. Now, for cosecant, secant, and cotangent, excuse me, what we want to notice is that these are just the reciprocals of the first 3. Right? So cosecant is just the reciprocal of sine. Notice that sine is opposite over hypotenuse. Okay, opposite over hypotenuse. Okay, cosecant is the exact opposite, hypotenuse over opposite. Cosine is adjacent over hypotenuse. The secant is the hypotenuse over the adjacent. Okay, and cotangent is just the reciprocal of tangent. So the trick becomes just to remember what goes with what. Well, cotangent obviously is going to go with tangent. Right? And then the other 4, okay, just remember that no other goes with another co, right? So cosine can't go with cosecant, so cosine has to go with secant, okay? Whereas cosecant would have to go with sine, right? So no two cos can go together, and really that's true for tangent and cotangent as well, right? So we can't have any cos going together. So cosine can't go with cosecant, so it has to go with secant. So that's how I remember the relationship. So cosine is the reciprocal of secant, okay, sine is the reciprocal of cosecant. All right, so let's look at an example of evaluating 6 trig functions, okay, for an angle. So in my right triangle here I have the 2 legs of 5 and 12. I don't know the hypotenuse. So to find the hypotenuse when you know the 2 legs, okay, this is why we reviewed the Pythagorean theorem. So finding that hypotenuse, we are going to take the square root of 5 squared plus 12 squared. Okay, which would equal 169, so the square root of that is 13. So the hypotenuse here is 13. All right, now the 6 trig functions. So sine, so let's start with sine, cosine, and tangent. So All right, so sine of theta is going to equal the opposite over the hypotenuse. Right, so again, 13th is the hypotenuse. Okay, the other side that helps make our angle right here is the adjacent, leaving the 12 over here, the third side, as the opposite. All right, so sine of theta is going to be opposite over hypotenuse, so 12 over 13. Cosine of theta will be the adjacent over the hypotenuse, so 5 over 13. The tangent of theta will equal the opposite over the adjacent, so that would be 12 over 5. All right, then if you do the reciprocal functions, okay, tangent is going to go with cotangent. Okay, so the cotangent of theta will equal just the reciprocal of 12 over 5, so 5 over 12. Okay, cosine is the reciprocal of secant, so the secant of theta will be 13 over 5. And sine goes with the cosecant of theta, so that would be 13 over 12. And there are my 6 trig functions, okay, for that angle. And again, the trig function is going to be paired with an angle. Right? It's all dependent on where is the angle. Okay, if we're working with that angle, okay, that's different than if we're working with this angle over here. Okay, that would give you 6 different trig functions. All right, so that's how we evaluate trig functions. Just use the definitions. If we know the 3 sides, we can come up with all of the values for those trig functions. Now, some angles, okay, are special, okay, and we need to just memorize these trig functions for these 3 angles: 30 degrees, 45 degrees, and 60 degrees. Now, why these? Well, a 30, 60, 90 triangle is going to be exactly half of a equilateral triangle, and a 45, 45, 90 triangle is going to be exactly half of a square. So these are regular shapes. Okay, they're half of regular shapes. Okay, and regular shapes are used a lot in different applications. Okay, whether it be construction or architecture or design. Okay, of things that need to have that symmetry that a regular shape would have, like an equilateral triangle or a square. All right, so what you need to do is just take a minute, okay, write these down, and work on memorizing them. Okay, spend some time each day, okay, going through what these trig functions are for each one of these angles, and know them, because these are ones that are going to come up over and over and over again. Right, and when we get into looking at other angles, A lot of times we look at just multiples of these, 30, 45, and 60 degree angles. So this will keep coming back as we do trig, these values. All right, well that's it for part 1. Okay, we'll see you tomorrow for part 2.